In organic chemistry, we talk about typically 4 different intermediates. And these intermediates, it may be no surprise to you, in organic chemistry focus around the carbon atom. So these are really 4 carbon intermediates. The number 1 most common intermediate we will encounter is the carbocation. Now, carbocations we've already seen come in about 4 different flavors. There's the methyl. There is the primary carbocation, and we don't call that the 1 degree. We write 1 degree, but it's called primary. There's secondary, and when I write methyl groups on here, really I'm just saying these are R groups. We have other carbon groups coming off of here. They don't have to be methyls, it's just that methyls are really fast and easy to write on these slides. And then there's the tertiary carbocation. Now, these are not all carbocations are equal in terms of stability. It turns out some carbocations are easier to form as reaction intermediates than other carbocations. And in terms of stability, methyl is the least stable, and the tertiary ones are the most stable. And if this sounds familiar, we've talked about this. This is actually an exact picture that we took from our hyperconjugation slide. So we saw that due to orbital overlap, each time we put a methyl group or an alkyl group on this carbon, you need a plus. Every time we put a carbon group on here, that helps stabilize a positive charge. So alkyl groups are in some sense an electron donating group, and they stabilize that positive charge. Okay, so that's one trend. The other type of intermediate that we will encounter frequently are the, not carbocations again, silly, the carbanions. So what do the carbanions look like? They look the exact same. Now we're going to have a carbon with a lone pair. It's going to have a negative charge. And we don't have to have just hydrogens on those carbons. We can put other alkyl groups. Carbanion, and we can put up to 3 alkyl groups off here. Carbanion, so again, this would be the methyl carbanion, primary carbanion, secondary, tertiary. As it turns out, the stability trend for carbanions is the opposite of carbocations. So this is the most stable, while the tertiary is the least stable. And that's again related to hyperconjugation. You can imagine if these alkyl groups are donating electron density, this carbanion says, please quit donating electron density. I already have plenty. So the more donating groups we have on this carbanion, the more the carbanion says, I am unstable. Whereas fewer carbon groups is good, and you get the most stable structure. The third type of intermediate, which we will see barely at all in this class, are the carbon-centered radicals. Now I'll draw a couple of these out. This would be the methyl radical. Radicals have an unpaired electron to them, so it's a single electron species. And we could draw primary, I'm not going to draw it, but we could, secondary, and let's draw tertiary, where we have 3 R groups. In this case, I've shown methyls. And so radicals actually follow a trend much like carbocations. So this is the least stable, and this is the most stable. I'm not emphasizing this much because we're not going to see many radicals in this course. What's the fourth type of carbon intermediate? These are the carbenes. Now, I consider these weird, and I don't teach them at all, but it's a carbon that bears two different groups and a lone pair. So it's neutral with two groups. It's just a really strange species. We won't talk about carbenes, but technically, to complete the list, everybody has to know that there are 4 carbon intermediates, and they are carbocations. We'll see them a lot. Carbanions, we'll see them a lot, but they'll be later in the course. Radicals, we won't see them much in this course, but they are still important. And carbenes, which are just sort of out there. So those are the 4 intermediates that you encounter in organic chemistry.